so we'll take a look at it. All right, so here you had 8, 4, 2, 1, 1/2, 1/4, 1/8. Yeah?
Yeah, same as the top.
Same as the top.
Yeah.
It's exactly the same as the top. So what we're finding is that, and as we graph it, let's go ahead and graph it. -3, 8, 4, 2, 1/2. So it does the same thing. Oops. Which means that the domain is exactly the same. 0 to infinity. Wait. Infinity to infinity. Negative infinity to positive infinity. My bad. The range, 0 to infinity. And the asymptotes are, again, y equals 0. Exactly the same. So we're finding, or hopefully what we figured out, is that this y equals 2 to the negative x is the same thing as 1/2. Is it 1/2? What was the other one?
1/2 to the x.
Yeah, 1/2 to the x. And we kind of expect that. Why do we expect that? Because 2 to the negative x is the same thing as 2 to the negative 1 to the x. Remember, we can separate these out. I don't know if you folks remember, but like 2 to the 3/2 is the same thing as 2 to the 1/2 to the 3rd, or I can move them the other way, but 2 to the 3rd to the 1/2. So you can take these, whatever, these folks multiply, power to power, you multiply them. So these are the same thing. What's 2 to the negative 1? 1/2. Right, remember, negative 1 means you take 2 and instead of multiplying by it, you divide by it. Do you remember that?
Yeah.
Use reciprocal, right?
Right. 2 to the 3rd, yeah, is 1 times 2 times 2 times 2. 2 to the 2nd, 1 times 2 times 2. 2 to the 1st, 1 times just 1 2. 2 to the 0, 1 times no 2's at all. 2 to the negative 1, now we do the opposite of multiplying, we divide. 1/2, right? 2 to the negative 2, 1/2 times 2, 1/4. Folks remember that negative exponent means you divide by it instead? So that's why this is not surprising. If you kind of break it out that way, you'll realize that 2 to the negative x is really 2 to the negative 1 to the x, which is 1/2 to the x. So that's why they're the same. But some good things to know as you head into your homeworks for that. Okay, so now we're going to take a look at the next handout, which is exponential versus linear versus quadratic. So we're going to introduce ourselves to a new type of function called an exponential function. Previously, we learned about linear and quadratics. Linear function is where one quantity changes by adding a constant or subtracting a constant each time as x changes. Quadratics, it changes as the power of the, it changes as the power of whatever x is. Like, so in other words, it changes by x squared amounts. But this one changes even more crazy. So for example, in every house, there's some chore that no one wants to do, right? Whatever it is, picking up all the dog poop or whatever it is, right? There's some job. It's so popular that person who's willing to do it can pretty much name their price. Suppose you volunteer to do the chore and you ask to be paid according to the following rule. $1 for agreeing to do the job, plus 10 cents for every day that you perform the task. If you did it every day for a month, how much money will you be paid at the end of the month? All right, so we're going to kind of look at these tables here to help us figure that out.
Be $4.
Yeah, that seems right. So how do you find that? Well, the first day you get $1 plus no 10 cents, right? Second day you get $1 plus 1 10-cent because you've done it for one day. Second day, $1 plus you get 10 cents twice, $1.20. So fourth day would be $1, 1 plus how much? 10 cents times 4. What would it be for, is that supposed to be an M? What do you have, what do you folks have in your handout here?
It's cut off, it could be an M, yeah, it could be a capital M, I'm not sure.
Well, let's make it 10. How much would you get paid after 10 days? Everyone find out how much you get paid after 10 days. But can you all see the pattern kind of happening here? $1 plus 10 cents times 1 day. After 2 days, $1 plus 10 cents times 2 days. After 3 days, $1 plus 10 cents times 3 days. David, what's the pattern? What would 10 be? $1 plus what?
Plus 10.
Plus 10 like that? Well, look, what's the pattern? Can you see a pattern through here?
Mhm.
What's the pattern?
Just keep adding each day, you just add another day. You increase the value by 1 for each day.
Yep.
Yeah. So 0.10 times 10.
0.10 times 10. Good. What would it be for x, Ryan? 1 plus what?
For x.
Mm-hmm. See the pattern? 0 days, 0.10 times 1, 0. After 1 day, 0.10 times 1. After 3 days, $1 plus 0.10 times 3. After 10 days, $1 plus 0.10 times 10. What would it be for x?
10 times x.
Yep, $1 plus 0.10 times x. Can folks see that pattern?
Yeah.
Again, it's whatever's here goes there. Do you see whatever's here goes there, whatever's here goes there? Shania, do you see the pattern? Whatever's here goes there. Okay, so let's go ahead and graph this. So after 1 day, how much money do I have? $1. Well, after 0 days, I have how many? How much do I have after 0 days?
$1.
$1. After 1 day, how much do I have? How much do I have? Deja, how much would I have after a day?
$1.10.
So $1, 1.1. Right there. Shania, what do I have after 2 days? Shania, what do I have after 2 days?
$1 plus 10 times
Yeah, which is how much?
$1.20.
Great. So after 2 days, so I'm going down here the number of days. 2 days, I have, going up the amount of money I have, $1.20. Is everyone seeing where those are coming from?
Mhm.
Okay. David, after 3 days, how much do I have? How much money have you made after 3 days?
$1.30.
Yep. Eric, after 4 days?
$1.40.
Yep. Natalia, after 5 days?
$1.50.
Great. See how it makes a line? It makes a straight line. Anyone see that?
Mhm.
This is linear. That makes sense, right? It should make a straight line. Okay, good. Now, so what kind of function is it?
Linear function.
Linear. So after the end of 30 days, how much money should you make? I want to find out how much money you should make after 30 days. How much money should you make after 30 days? Check with your neighbor. Ryan, David, check with your neighbors.
Yeah, so yeah.
So it's 1 plus 0.10 times whatever your number of days is. Now, did you get it yet?
I think so.
What did you come up with?
I got my whole.
Okay, so Ryan, what's, after 30 days, did you come with an answer yet? $1 plus 10 cents times, what should be the number that goes inside of here?
30.
30. Good. So, Tanya, what'd you get?
$4.
$4. Good. Great. And then the month, you realize this was not a very good deal. You decide to renegotiate your salary. So here you propose the following plan. You agree to do 1 cent for agreeing to do the job. On the first day you do the job, and for each additional day afterwards, you double the money that is owed to you. So in other words, 1 cent for agreeing to do it. After you do it 1 day, you get double that, 2 cents. If you do it the next day, if you do it 2 days in a row, then the next day you get double 2 cents. You get 4 cents. Making sense? Everybody
Mhm.
good with this part? Okay. So what happens? What do we get? Well, let's see. You're going to double it each time. So the first day, you get 1 cent. Sorry, the 0 day, you get 1 cent. Second day, you get the 1 cent doubled. So you multiply it by 2 to the 1 power. So again, 1 here, 1 there. 0 here, 0 there. The second day, you get 1 cent times 2 to the 2nd power. Third day, you get 1 cent times 2 to the 3rd power. What would be the formula for the 4th day? What's the pattern?
1 times 2 to the 4th power.
0.01 times 2 to the 4th power. I'm gonna put a parentheses because I like that better for multiplying. The x gets me confused with x's itself. Okay, so 30 days later, or let's do 10 days later. 10 days later. Deja, what should be my formula?
I read it out a little bit differently, like how the top one, so I did 10 cents equals to 10 times point, well, 1 cent is equal to 1 cent times 2 to the 10th power.
Okay,
Like I
1 cent, yep,
read it all the way out.
1 cent times 2 to the 10th power. You have it like that? Great. Does that seem all right with folks? So then what about x? What would be for x after x days?
.01 times 2 to the
1 times 2 to the, yep, times 2 to the x. Good? All right, so now the question is, what will it be after 30 days? I would find what it would be. 0.01 times 2 to the 30th. I'm going to bust out your calculator, find 2 to the, and I would suggest you go from the parentheses backwards, so do the parentheses first. So always start from the inside and work your way outwards. So in the parentheses, 2 to the 30th, do that first, and then multiply that by 0.01. Everybody do it. Do it, do it, do it. Do it. 2 raised to the 30th power, enter, and then times 0.01. Yeah. So here, you end up getting 2 to the 30th is some huge number, and then you multiply that by 0.01, it becomes slightly less huge, but it's still really big. Here. Two raised to the 30th, ginormous number, times 0.01, still a really big number. You're going to get 10,737,418.24.
Yeah.
Crazy, crazy lot, right? You can't, what was that? Can you see it again? It's a lot, right? So yeah, you double your money every day you work. So what you notice is, if you did it for 29 days, so 29 days, it would only be half of that. 5,360, 17.8, something. $700 or something like that, right? So if you only did it for 28 days, it would be, it'd be less than that. So it'd be like 26, $2.65 million, right? So those last few days is where it really starts to add up, right? It's this whole thing getting really bigger, a lot bigger. So let's go ahead and compare the two numbers we found. So for the linear, right, it was, after 1 day, it was $1.10, $1.20. So do all your linears for 8 days. I'm going to do all your linears for 8 days. And then do all of your exponentials for those same days. So this was 0.02, I think it was, 0.04. So these ones, you're just adding 10 cents each day on the blue group for the linear. And the red ones, the exponential, you're doubling them each day. So go ahead and do that. Do both of those. Do them. You don't need to calculate. Well, you could use a calculator if you want to. But all you're doing with this one is you're adding 10 cents, add 10 cents, add 10 cents. Right? This one you're just going to double it, double it, double it.
Oh, you're not putting the total?
Nope.
Oh.
We're doing this down here.
Oh, right.
Double, 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 double. When you're done with that, do 9 and 10 also. So here we've got $1.30, $1.40, $1.50, $1.60, $1.70. And over here we have 4 cents, 8 cents, 16 cents, 32 cents, 64 cents, $1.28, $2.56, $5.12, $10.24. Yeah? Okay. Now, we're going to sketch these two on the graph below. So my blue one, linear, start with $1, then I have $1.10, $1.20, $1.30. Oh wait, that's not right. No, nope, this is going up some weird amount. So, $1.10. After one day, I have $1. Oh, I see. Hold on. 0 days, I have $1. After one day, I have $1.10, $1.20, $1.30, $1.40, $1.50, $1.60, $1.70, $1.80, $1.90, $2. Well, that's not very exciting, is it? Like that, I gotta read down a bit, that it's, you know, roughly something like that. Something like that. Yeah. Okay, and then the red one, I start off with 1 cent, 2 cents, 4 cents, 8 cents, 16 cents, 32 cents, 64 cents. Am I at the right spot? 64 cents, yeah. $1.28, $2.56, $5.12, $10.25 or something like that, 24 cents. So it goes something like that. Crazy, right? Nothing for forever, and then all of a sudden it starts to pick up steam and just go, whoop. Right? So, does someone have something sort of like that? So if you perform the task for only 5 days, which one would you prefer? The linear or the exponential? Which one?
Exponential.
5 days? You'd rather have 32 cents versus $1.10, $1.50?
Oh, okay. 5 years.
5 days, I'd say the linear.
Okay.
So does everyone sort of see where 5 days, the blue one's ahead at 5 days.
Okay.
What about 10 days? Which one's better at 10 days? Which one's ahead at 10 days?
Oh,
Exponential. So I guess my question is, on which days is it better to switch from linear to exponential?
Day 8.
Day 8. Yep. That's where it changes over. Good. All right, let's take a look at the next page. Oh, we already did this. Didn't we already do that?
Yeah, the 30-day month.
Yeah.
Yeah.
Oh, I didn't, I did that ahead of time, my bad. All right, so now we're going to compare the 3 types of tables. See how they change. So, the first one is just linear, y equals 2 times x. So what's negative 2 times 2?
Negative 4.
Negative 4. We're just multiplying each of these by 2, doubling each one of these. Does everybody do that? Is this what everybody has?